Let's discuss Unit 4 Database Management System Solutions. Create table T in SQL is an example of. So this is actually a statement, a kind of command that is asking to create a table. So definitely normalization and primary key will not be the option. Knowing the basics of SQL, we all must know create command belongs to DDL. So we'll just see what are the commands. DDL is data definition language. Most commonly used commands are create, alter, drop. Create is to create a table. Alter is to modify the table fields and the constraints. Drop is to delete the table completely. Next we have DML, data manipulation language. This is to work with the data inside the table. We have 4 commands: insert, select, update and delete. Insert is to insert values, select is to retrieve values, update is to modify the values of the fields, and delete is to remove the complete row or remove the complete record. So create table T belongs to DDL. Option number 3 will be the right answer. Next question, which one of the following statements are correct? Granularity is the size of data item in a database. The size of a data item is called its granularity, and it can be a field of some record in the database, or it may be a larger unit such as a record or even a whole disk block. The statement says it is the size of the data item and granularity is the right term, so A is correct. From this we can rule out option 4. They are saying the size is granularity, but the data item can be anything. It can be a field, or it can be a record, or even a whole disk block. So this it refers to the data item. Next statement, 2 operations in a schedule are said to be in conflict if they belong to the same transaction. 2 operations in a schedule are said to be in conflict if they satisfy all 3 of the following conditions. What are the conditions? They have to belong to different transactions. They have to access the same item X, and at least one of the operations is a write operation. B says it is said to be in conflict if they belong to same transaction, which is totally wrong. The official answer has been marked as option number 2, which includes B. In fact, all the options include B, but it is false. The next statement, 2 schedulers are said to be conflict equivalent if the order of any 2 conflicting operations is the same in both schedules. When transactions are executing concurrently in an interleaved fashion, then the order of execution of operations from the various transactions is known as a schedule or history. So now comes the statement. 2 schedules are said to be conflict equivalent if the order of any 2 conflicting operations is the same in both schedules. If the order is going to be same in both the schedules, then definitely it will be conflict equivalent only. When we have change in the order of execution, it need not be in conflict. In that case, we can mark C to be true. So the next statement, write operations which are performed without performing the write operation are known as blind writes. A blind write is a write operation in a transaction T on an item X that is not dependent on the old value of X. So it is not preceded by a read of X in the transaction. Write operation is performed without performing read operation. Say we have a data item called X. Before writing the value of X, we have to read X and then only we have to write X. In case you have read the value of X at time t0 and this is at time t5 and this is time t6. If I use the value of X at time t0 here and then make a write operation, it is said to be blind write. Write operations which are performed without performing the read operation is known as blind write. That is what is given inside the brackets here. Write performed without read operation. So they say it is not preceded by a read it is not dependent on the old value of x, that is the read of x. Instead, it is blindly writing it. So whenever you want to update, you have to first go with the read operation, is what they say. When the read is missing, it becomes a blind write. So D is also wrong here. A and C only will be the right options here. So none of the options are matching this, but this is the official key. So A and C only are right, B is not right. Next question. Which of the following are not correct statement? Seeing the statements, you can ask, this might belong to data structures. Of course, this is a data structure statement too. But the thing is, here the statement, the first record in each block of data file. And when they say it is about dense index for index entries and searching is harder in B plus and B tree, and when they talk about extendable hashing, all these are part of file organization in DBMS. The first record in each block of data file is known as actor record. So we have something called primary index. The first record in each block of data file is called the anchor record of the block or the block anchor and not actor record. So A is false. Next, dense index has index entries for every search key value in the data file. This is true. So whichever options include B has to be ruled out now. Option number 2 will be the right answer. Searching is harder in the B plus tree than B tree as all the external nodes link to each other. What is the right statement? The search is faster in B plus tree than the B tree as the keys are present at leaf nodes. So this statement is totally wrong and we will mark it as false. So in the context of B plus tree, they say the search is faster. And where this content comes about anchor record is in primary index. That's why I have given the context of the statement as primary indexes. Next statement. In extendable hashing, the size of the directory is just an array of 2 power d minus 1 where d is global depth. Extendable hashing is a dynamically updatable disk-based index structure which implements a hashing scheme utilizing a directory. The index is used to support exact match queries, that is, find the record with a given key. This directory has the form of an array with 2 power d entries, each entry storing a bucket address, and d is the global depth of the directory. An array of 2 power d minus 1 is wrong, so d is also false. So option 2 will be the right answer. Next question. Match list 1 with list 2. We are given the normal forms in list 1 and their explanation in list 2. What is the first normal form? We have to have atomic values. What does atomic mean? We have to have single value for fields. The other term for this is, we can say, scalar values. 1NF, if and only if all underlying domains contain scalar values only. Domains in the sense, the fields or the columns. So C will be mapping to 2. The only option where we have C mapping to 2 is option number 2. So option number 2 will be the right answer. This is joint and MVD is multi-valued dependency. FD is functional dependencies. So you have the order of 1NF, then 2NF, then 3NF, then we have BCNF, then we have 4NF, then we have 5NF. This is about atomic values. This is about partial dependency should not exist. So fully functionally dependency should be there. Then transitive dependencies should not be there. So this is partial should not be there. Then 4NF is about multi-value dependencies and 5NF is about joint dependencies. When the functional dependencies is implied by the candidate keys, we can say it belongs to BCNF, Boyce Codd normal form. So A will be mapping to 4. So this is FD on candidate key. Then we have 4NF, if and only if every multi-valued dependency is implemented by the candidate keys. So here D will be mapping to 3. Then 5NF, if and only if every joint dependency is implied by the candidate keys. So generally they will say multi-valued should not be there. Joint dependency should not be there. But Except for the candidate key, there should be no multi-value dependency. Except for the candidate key, there should be no joint dependencies. This is what the statement says about 4NF and 5NF respectively. So they have given JD implied by the candidate key, MVD implied by the candidate key. Similarly, FD is implied by the candidate key. So option 2 will be the right answer. Next question. We will be having consecutive 5 questions based on these two relations. So we have two relations X and Y. In X we have 3 fields S, Si and C. In Y we have 3 fields S, P and D. From this we can say these two fields are same. Now we have a set of operations and their particular symbols. Cartesian product is represented like this. Join is represented through this symbol. Left outer joint is where the left side will have a symbol like this. Right outer join is where right side will have the symbol. When it is full outer join, that symbol is present in both the sides, and when it is semi join, one side will be open. Only with the help of these symbols we are going to work with the next 5 questions. The first question, find the number of tuples by applying the operation. The operation is given as X left join, where the condition is X dot S field is equal to Y dot S field in the Y relation. So this symbol is left join. So what is left join? In left join, operation allows keeping all tuple in the left relation. Everything will be present from X. If there is no matching tuple in the right relation, then the attributes of the right relation are filled with null values. Now the result of this left join will be like this. So I have J, B, R, T, 1, 2, 3, 4, M, N, H, E from X. Till here it is X. So these two are from Y relation. So we have J. So the corresponding S1 and CA are entered. Then we have B in both the relation. So P1 and AB are entered. Then we have R. So D1 and DC are given here. We have T in this particular relation and A here. So this tuple will not be taken into consideration. Instead, the equivalent values will be filled with null if there is no matching tuple. So what is the matching condition here? X dot S and Y dot S. This is Y dot S and this is X dot S. This is the matching condition. So J is equal to J, it is included. B is equal to B, it is included. R is equal to R is also included. Since we don't have any T, the attributes of the right relation of the joint result are filled with null values as specified here. So how many tuples are there by applying the operation? There are 4 tuples. Option number 3 will be the right answer. And tuples are nothing but the records. Next question. The result of X right join. This is the symbol of right join on the attribute X dot S is equal to Y dot S condition from the relation Y. So what is right join? Operation allows keeping all the tuple in the right relation. It means J, B, R, A will be present and T should not be present. So whichever options included T will be ruled out immediately. If there is no matching tuple found in the left relation, then the attributes of the left relation in the joint result are filled with null values. They have given none of these, so we have to check if option 2 is having the answer. So yes, J, B, R, A is there. Then the corresponding P and D values are present in all the 4 records. And we have only J, B, R in X and Y together. So 1, 2, 3, M and H are filled. But since we don't have T record, the corresponding SI and C field value are filled with null. Whatever we did with left join, the same thing we are doing with right join, but in that case left side tuples are included and right side whichever is not available we are filling with null values. Here right side tuples are filled, S1, P1, D1, H1 is filled, CA, AB, DC, MD are filled, and whichever values don't have a matching left side are filled with null values. That is SI and C fields are having null values. So option 2 will be the right answer and none of these is also ruled out. Next question. Which of the following join is used to get all the tuples of relation x and y with null values of corresponding missing values? So in left we had tuples only from the left side and the missing values from the right relation are filled with null values. In right outer join, we took the tuples from the right relation and whichever values missed in the left side are filled with null values. So the definition of left outer and right outer is not matching here. We have to check for the other two joins. What is a natural join? It can be performed if there is a common attribute between the relations. The name and type of the attribute must be same. See, even when you make left or right, they said x dot s is equal to y dot s. In natural join also we can say this. So both these value belong to the same type as well as the name is also same in both the relation. So this is the common attribute they are talking in natural join. But here only when the condition is matching the tuples will be taken out in natural join. But here they are saying all the tuples should be taken out. So we know it is not left outer, not right outer and not natural 2. Obviously option 4 will be the right answer. In full outer join, all tuples from both the relation are included in the result irrespective of the matching condition. And of course the corresponding missing values will be filled with null values. Now let's see the result of full outer join. So we have included S, Si and C from X and S, P and D from Y. So J, B, R, T, A. All the tuples are taken. For T we don't have corresponding values in P and D. So we are filling it with null. So these are the missing values that are filled with null. At the same time for A record we don't have X related fields, so we are filling this with null. In fact, we are combining left as well as right joins together to bring this full outer join. Next question. Number of tuples by applying right outer join on relation x and y are. Question number 5087. They have applied right join operation. So let me bring that result from the option. We have marked option 2 right. In question number 5087, ID the last 4 digits I am saying. So this was the answer. Now how many tuples are there? 1, 2, 3, 4. Option number 4, 4 will be the right answer. So this is the result from question ID 5087. We marked option 2 for right outer join. So the symbol was x dot s is equal to y dot x on y. So they have directly given the result in that question and they are asking for the number of tuples in this question. Next question. Number of tuples obtained by applying Cartesian product over x and y are. So what is a Cartesian product operation? It's an operation used to merge columns from two relations. Here the relations are x and y. It is also called cross product or cross joint. So I will give you the result of the Cartesian product here. In this result till here it is x relation and from here it is y relation. So how we have got this Cartesian product is every tuple from x have to be merged with every tuple of y. So let's take the first tuple from x, J1M. So here the entry JBRA is available from y. This is for the first tuple of x. Now the second tuple of x will have all these 4 tuples merged here. Then the third tuple of x will have 4 tuples from y merged like this. Then the fourth tuple of x will have 4 tuples from y merged like this. You have 4 tuples here, 4 here, 4 here and 4 here, which gives a count of 16. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. So how can we in general without seeing the result find the number of tuples is, you just count the number of tuples in x, it is 4 and number of tuples in y is also 4. So when you multiply these two, you will get a value of 16. So the number of tuples in x into the number of tuples in Y will give you the number of tuples of the Cartesian product over X and Y. So option number 1, 16 will be the right answer. With this, we are completing Unit 4 questions.